All right, so we have seen quadratic functions in ABC form. We've seen quadratic functions in vertex form. What about a quadratic function in factored form? So we'll see how this can help us, how we can still find all of our characteristics of the quadratic function, but when it's in factored form, and how this relates to the other forms as well. All right, let's jump right into it. So properties of graph: f of x equals a times x minus p times x minus q. So this is what we call factored form. We call it factored form because it's what we get when we factor. All right, so what does this information tell us? It tells us a lot, actually. So because f of p equals 0 and f of q equals 0, p and q are the x-intercepts. We can see that here and here, right? So this is the point p comma 0, this is the point q comma 0. We don't know exactly where they are, but we know that those are the x-intercepts of the graph. So when we have factored form, we can easily find the x-intercepts. Remember, the ABC form, or the standard form, was really good for finding the y-intercept. The other thing is, notice that the axis of symmetry is halfway between the x-intercepts, p comma 0 and q comma 0. So the axis of symmetry is the average of those two values. How do we find the average of two values? We add them and divide by 2. How do we find the average of any amount of values? You add all of them and divide by how many values. So I know the axis of symmetry is going to be the line x equals p plus q over 2. Remember that this is also the h value of the vertex. So this is how we can find the vertex if we have factored form, is we can find this x coordinate, or the h coordinate of the vertex, by averaging the p and the q. If a is positive, the parabola opens up. If a is negative, the parabola opens down. This is the same a that we have in vertex form and in standard ABC form. So the a value has the same effect on the graph. It's going to either make it open up or make it open down. All right, let's do an example. So I want a graph. F of x equals -2 times the quantity x plus 3 times x minus 1. I want to label the x-intercept, the y-intercept, the vertex, the maximum and minimum value, maximum or minimum value, the domain, the range, the increase in intervals, the decrease in intervals, and the axis of symmetry. Ooh, where do I start? Good question. Let's actually start with the x-intercepts, because those are going to be the easiest thing to find, based on the form that we have. So if I set the function equal to 0, that's how we find x-intercepts. Now, if I set each factor to 0, the 2 is going to go away, because if I say 0 equals -2, that's not true. So I get x equals -3 and x equals 1. So my x-intercepts are the points, and I want to write them as points: -3, 0, and 1, 0. So I'm going to go ahead and plot those. 1, 2, 3, 1. Boom. Now, let's go ahead and find the y-intercept. So remember, to find the y-intercept, we plug in 0 for x. So f of 0 is -2 times 0 plus 3 times 0 minus 1. So this is -2 times 3 times -1, which is +6. So therefore I know my y-intercept is going to be the point 6, comma 0. I'm sorry, I miswrote that. 0, comma 6. It's a y-intercept. So my y-intercept is going to be there. The x coordinate of the vertex, remember we get that by averaging the x-intercepts. So if I take the x-intercepts, I do -3 plus 1 over 2, this is going to equal h. This becomes -1. The k-coordinate is, remember, f of h. So I'm going to do -2 times -1 plus 3 times -1 minus 1. This becomes -2 times 2 times -2, which is 8. So I know I have a vertex of -1, 8, which also tells me then that I have an axis of symmetry of x equals -1. So I'm going to plot my vertex, which was at -1, 8, and now I can draw a little bit more of the graph. Because of symmetry, I know that there's going to be a point here, and so the curve is going to look kind of like this. Alright, now we still need to find a bunch of other information, right? So we have our x-intercepts. Those are here and here. We have our y-intercept. That is right there. We have our vertex. Which is right here. And so now we want to find the max or minimum value. We know that is going to relate to the vertex, and in this case it's going to be a maximum. So our max value is going to be 8. The domain is always -∞ to infinity for a quadratic function. The range is -∞ to 8. Remember, that is our maximum value. And then the last thing we are doing are increasing, decreasing intervals and our axis of symmetry. So we already actually identified the axis of symmetry. I'm not going to draw it in on the graph, but our increasing intervals, so let's say increasing is going to be -∞ to -1, and then decreasing is going to be -1 to infinity. And we can see that from our picture here. So this is our increasing and then decreasing. Okay, so this one I want you to try on your own. Big surprise, I know. So I want you to graph this, but the big thing is, can you identify all of these key features as well? So pause the video, try to identify all those, use our last example to help you. Pause when you're ready to discuss. Alright, so I think I got everything here. Let's look at it. X-intercepts, -1, 0, and -5, 0. I plotted those, and I got those by setting each factor equal to 0. Y-intercept, I plugged in 0 for x, and I solved, and I got 0, -5, so I plotted that point there. Vertex, so if I average the x-intercepts, I got an h value of -3, and I plugged that into the function, and I got +4. So the vertex is the point -3, 4. So that's right there, which means my axis of symmetry is x equals -3. It also means that I have a maximum value, and I know that because my a was negative, right, in front of the function was negative, so the parabola opens down, so the y-coordinate of the vertex, where k is my maximum value. Domain is negative infinity to infinity. Range is negative infinity to that maximum value, which is 4. My increasing and decreasing intervals are negative infinity to negative 3 for increasing, where the negative 3 comes from the x-coordinate of the vertex, and negative 3 to infinity for decreasing. All right, let's try one more of this type of problem. Again, I want you to try this on your own though, so pause the video, try to find all this information. Unpause when you're ready to discuss. All right, so hopefully here we got the same information again. Let's talk about it. So up here I got my x-intercepts at 6, 0, and 2, 0 by setting each factor equal to 0 and solving for x. And so we can see that on my graph here, and sorry, I will actually draw in the graph. So here are my x-intercepts. I got my y-intercept by plugging in 0 for x, and I got 0, 3, so there's my y-intercept. I got the h-coordinate of the vertex by averaging the x values from the x-intercepts, and that is 4. So then when I plug that back into the original function, I get negative 1 for the k, or y-coordinate of the vertex. So the vertex is at the point 4, negative 1. That's right there. Axis of symmetry then is x equals negative 4, and this is going to be a minimum value because the a value of the function was positive. So the minimum value is negative 1, which is the k-coordinate of the vertex. Domain is negative infinity to infinity. Range is that minimum value, so negative 1 to infinity. And then this function decreases first, so I wrote that first, so it's negative infinity to 4, which is the x-coordinate of the vertex. And then it's increasing from 4 to infinity. All right, let's try a quick application problem. So here we have the parabola shows the path of your first golf shot. So this is the picture that they're saying that's your first shot, where x is the horizontal distance in yards and y is the corresponding height in yards. The path of your second shot can be modeled by this function. So I want to point out this function is not this graph. Which shot travels further? Which shot travels higher? So I want you to try to think about this. Do this on your own. If you get stuck though, remember, you can always just unpause and listen to me talk. So pause the video, try this on your own. Okay, so we have two parts to this question, right? Which one traveled further and which one traveled higher? So to talk about distance, we know that the horizontal distance is how far something goes, right? And so in this case, that's the x-intercepts. So from the graph, I can see I have an x-intercept at 0, 0, and I have an x-intercept at 100, 0. So what I need to do is find the x-intercepts of this equation. So I set each factor, I set the whole equation equal to 0, then I set each factor equal to 0, and I get x equals 0 and x equals 80. So the equation has x-intercept of 0, 0, and 80, 0. Therefore, the picture graph, this went further because it went from 0, 0 to 100, 0. So it went 100 yards, this went 80 yards. Now to find which one went higher, I have to find the maximum. Again, from the graph, I can actually see the maximum. So the maximum value here is 25. That is the y-coordinate of the vertex right here. That's at 25. For the equation, I have to find that. So I average the x values of the x-intercepts, and I get 40. Then I plug that back into the original equation, and I get 32. So this value is higher, or larger, than the maximum of the graph, which was 25. So this travels higher. Okay, so to kind of conclude what we've done so far in this unit, we've seen vertex form, standard form, which is also called ABC form, and factored form. And we've seen from all of those different forms how we can find the vertex, the x-intercepts, the y-intercept, increasing and decreasing intervals, the domain, the range, the maximum or minimum value.